In the quiet, ordered workshop of the cosmos, there are rules. There are gentle, reliable recipes for creation. We believe we know the recipe for a planet. We believe we understand the delicate dance of gravity, dust, and time that is required to build a world. We look out into the vast, dark ocean of space and we see what we expect to see. Countless worlds, all born from the same cosmic cookbook, all following the same fundamental laws. But every now and then, in the faint, distant light of a faraway star, we find a ghost, an anomaly, a world that tears up the recipe book and throws it into the void, a planet that, by all rights and by all our carefully constructed logic, simply should not exist. And it is in these impossible worlds, these beautiful and defiant exceptions, that the universe reveals its true, creative, and mysterious heart. Hello there, and welcome back to the Drowsy Cosmos, our quiet little corner of reality where the deepest cosmic puzzles become a gentle, winding path to a peaceful night's sleep. Tonight, we are embarking on a journey not to a place of order, but to a place of beautiful defiance. We are going in search of the planets that shouldn't be there. And as we begin our quiet expedition together, scattered all across our own small, gentle world, I would love to know, what does the sky look like from where you are tonight? Is it a brilliant canopy of familiar stars, or is it hidden behind a soft blanket of clouds? Whatever your view, it is a perfect reminder of our own place in this grand unfolding mystery. If you find this gentle journey into the unknown helps to soothe your mind and quiet your spirit, I would be so very grateful if you would give this video a like and perhaps subscribe. It helps this peaceful exploration society of ours reach other souls who might be searching for a calm and gentle wonder to contemplate before they drift off to sleep. And as always, please remember that this is a journey without expectation. If my voice becomes a soft, steady hum and these ideas a comfortable pillow for your thoughts, then our mission is a beautiful success. So now let the familiar world around you begin to fade. Let your body grow heavy, comfortable, and still. And let us travel together to the edge of possibility to meet the worlds that broke all the rules. Our story begins here, in a place that feels like home. A calm, orderly, and relatively peaceful corner of the Milky Way galaxy, our own solar system. It is our primary example, our blueprint for how a family of planets should be born and raised. The story, as we understand it, is a gentle and patient one. It begins with a star, our sun, born from a vast, swirling cloud of interstellar gas and dust that collapsed under its own gravity. As the young sun ignited at the center, the leftover material, the dust, the gas, the ice, flattened out into a vast, spinning record around it, a protoplanetary disk. This disk was not just a random collection of material. It was rich with the legacy of 1,000 generations of long-dead stars. It contained not just the simple hydrogen and helium from the beginning of time, but also a generous sprinkling of heavier elements: carbon, oxygen, nitrogen, silicon, iron. All the essential ingredients for building rocky worlds forged in the hearts of ancient supernovae and cast out into the cosmos. And in this rich, spinning nursery, the patient work of creation began. Gravity, the silent and gentle sculptor of the cosmos, started to pull tiny grains of dust together. These tiny grains formed larger pebbles. The pebbles collided and stuck together, forming boulders. The boulders gathered into planetesimals, the size of asteroids. And over millions of years, these planetesimals swept up the material around them, growing larger and larger, their own gravity becoming stronger and stronger in a slow, snowballing process of accretion. There was an order to this creation. In the warm inner regions of the disk, close to the young sun, only the rocky metallic elements could survive the heat. And so the small, dense, terrestrial planets were born: Mercury, Venus, Earth, and Mars. In the cold outer regions of the disk, beyond a boundary we call the frost line, it was cold enough for ices, water ice, methane ice, ammonia ice, to condense. This provided a vast extra reservoir of building material, and so the great giant planets were born: Jupiter and Saturn, the gas giants, which grew so massive they could pull in huge atmospheres of hydrogen and helium directly from the disk. And further out still, Uranus and Neptune, the ice giants. It is a beautiful, logical, and elegant story, a story of gentle accretion, of ordered zones, of patient gravitational growth in a relatively stable and resource-rich environment. And for a long time, we thought that this was the story. We assumed that most planetary systems in the universe would look something like our own, and then we began to find them, the other worlds, the exoplanets. For centuries, they were just a dream, a theoretical possibility. But in the late 20th century, our technology finally became sensitive enough to detect the faint, subtle clues that hinted at their existence. We learned to watch for the tiny, rhythmic wobble of a star being tugged back and forth by the gravity of an unseen orbiting planet. We learned to watch for the faint, periodic dimming of a star's light as a planet passed in front of it, an event called a transit, and the floodgates opened. Our telescopes, especially the incredible Kepler Space Telescope and now the James Webb Space Telescope, began to find them not one by one, but by the thousands. We have now confirmed the existence of over 5,000 exoplanets, and we know that there are billions, perhaps trillions more in our galaxy alone. The sky is filled with worlds. At first, many of these new discoveries seemed to confirm our theories. We found gas giants orbiting far from their stars and rocky worlds closer in. But very quickly, we began to find the outliers, the oddballs, the worlds that didn't fit our neat and tidy story. We found hot Jupiters, massive gas giants orbiting their stars so closely that their years last only a few days, a place where they simply could not have formed. We found super Earths, a class of planet that doesn't even exist in our own solar system. We found planets orbiting two stars at once, like the fictional world of Tatooine. The cosmic cookbook, it turned out, had far more recipes than we had ever imagined. But even among these strange and wonderful new worlds, some were so extreme, so utterly out of place, that they challenged not just the details of our theory, but its very foundation. They were the true anomalies. The planets that, when we found them, made us sit back and whisper to ourselves that shouldn't be there. And to meet the first and perhaps the most famous of these impossible worlds, we must travel to a very different kind of place, a place that makes our own quiet solar system seem like a tranquil garden. We must journey to the heart of a globular cluster. A globular cluster is one of the most ancient and beautiful objects in our galaxy. Imagine a vast spherical city of stars, a celestial beehive containing hundreds of thousands, sometimes millions, of ancient suns, all bound together by their mutual gravity into a single glittering ball. These are the old ones. The stars in a globular cluster were all born together in the very early days of the Milky Way, more than 10 billion years ago. They are the galaxy's first generation. To journey into one of these clusters with our imagination is to travel back in time. The light is different here. It is a soft, golden, and ancient light, cast by a multitude of old, red, and dying stars. The space here is crowded. The stars are packed together 1,000 times more densely than in our own quiet stellar neighborhood. From the surface of a planet within a globular cluster, the night sky would not be a dark canvas with scattered points of light. It would be a breathtaking, blazing canopy of brilliant suns, so close and so numerous that true darkness would never fall. It is a place of incredible beauty, but also a place of incredible gravitational chaos. The stars are constantly in motion, weaving intricate and complex orbits around the cluster's dense core. Close encounters between stars are common. The entire system is a swirling, chaotic dance of gravity, a cosmic metropolis that has been buzzing with activity for billions upon billions of years. And it is for this very reason that for a very long time, astronomers believed that globular clusters were the last place in the universe you would ever expect to find a stable planetary system. The gravitational environment was simply too violent. Any young, fragile protoplanetary disk would be quickly torn apart by the close passage of a neighboring star. Any young planet that did manage to form would be unceremoniously ejected from its solar system and sent hurtling into the lonely darkness of interstellar space. These ancient glittering cities, it was thought, were barren. They were cities without worlds. And then, in the heart of one such city, a globular cluster known as Messier 4, we found him. A planet that, by all rights, should not be there. Its official name is a string of letters and numbers, PSR B16020 26b. But astronomers, in a moment of poetic insight, gave it a much more fitting nickname. They call it Methuselah, after the biblical figure who was said to have lived for almost 1,000 years. And the name is perfect, because the first and most profound reason that this planet shouldn't exist is its almost unbelievable age. By carefully studying the age of the stars in its host cluster, astronomers have been able to determine that the planet Methuselah is approximately 12.7 billion years old. Let us pause for a moment to truly feel the weight of that number. Our own planet, the Earth, is a respectable 4.5 billion years old. The Sun is just a little older, but Methuselah is almost 3 times older than the Earth. It is a world that was born when the universe itself was just a toddler, only about a billion years old. It is one of the firstborn, a true cosmic ancient. And this is the first great impossibility. This is the first rule that it breaks. Remember our recipe for building planets? It required a generous sprinkling of heavy elements: carbon, oxygen, silicon, iron, the cosmic dust that is forged in the hearts of stars and scattered through space by supernovae. But 12.7 billion years ago, the universe was a very different place. It was anemic, it was metal poor, as astronomers say. The very first stars in the universe were made almost exclusively of the simple primordial elements created in the Big Bang: hydrogen and helium. These first generation stars had to live out their entire lives, burn through their fuel, and explode as supernovae just to create the first batches of heavy elements. And then a second generation of stars had to form from that slightly enriched material, live out their lives, and explode to create even more. It is a slow, patient, cosmic process of enrichment, like a gardener slowly improving the quality of the soil over many seasons. 12.7 billion years ago, the cosmic soil was still very poor. There simply shouldn't have been enough of the raw, heavy ingredients, enough of the cosmic dust and grit to form a planet. Especially not a giant planet like Methuselah, which is estimated to be about 2.5 times the mass of our own Jupiter. According to our neat and tidy theories, the universe simply hadn't had enough time to cook the necessary ingredients. And yet, there it is, a vast, ancient world formed from a cosmic pantry that should have been almost bare. It is a defiant testament to the fact that the universe, even in its infancy, was far more creative and resourceful than we ever gave it credit for. It found a way to build a world where, by all rights, no world should be. This is the first reason Methuselah is a ghost, an anomaly. It is a planet that seems to be older than its own building blocks. But its story gets stranger still. Its second great impossibility lies not just in when it was born, but where it lives. Its home is one of the most exotic and violent stellar systems we have ever discovered. Methuselah does not orbit a single, stable, sun-like star. It orbits a bizarre and fascinating binary pair, a celestial couple made up of two stellar corpses. One of its parent stars is a white dwarf. This is the dead, cooling core of a star that was once much like our sun. It is a city-sized diamond of super-dense carbon and oxygen, no longer shining from nuclear fusion, but glowing faintly with its own residual heat like the ember of a long-dead fire. Its other parent star is something far more extreme. It is a pulsar. A pulsar is a type of neutron star, one of the strangest and densest objects in the entire universe. It is the collapsed core of a massive star that has exploded as a supernova. It is an object with the mass of a sun, crushed down into a sphere no bigger than a city. A single teaspoon of its material would weigh billions of tons. And this particular pulsar is a millisecond pulsar, which means it is spinning on its axis at an incredible rate, hundreds of times every single second. As it spins, it sweeps powerful beams of radiation across the cosmos like a celestial lighthouse. And every time one of these beams flashes across the Earth, our radio telescopes detect a faint, rhythmic pulse. That is how we found this system in the first place. So, this is the home of Methuselah, a chaotic, ancient, and crowded globular cluster. And within that cluster, a bizarre solar system where it is forced to orbit a spinning stellar corpse and a dying stellar ember. One of its suns is a lighthouse that bathes it in intense radiation hundreds of times a second. The other is a fading ghost. And this is the second great reason that this planet shouldn't exist. Not only was it born at the wrong time, but it lives in the wrong place. Our tidy recipe for planet formation calls for a stable single star system, a place of gravitational peace and order. Methuselah lives in a place of constant gravitational upheaval and intense radiation. It is like a delicate ancient flower, somehow blooming in the heart of a perpetual storm. How could it possibly have survived for so long in such a violent and unforgiving home? The answer to that question leads us to the third and final impossibility of this incredible world. The story of how it came to be in this strange orbit is a tale of cosmic theft, of gravitational violence, and of an almost unbelievable series of coincidences. To understand this third great impossibility, we must become cosmic historians. We must try to reconstruct a story that took place billions of years ago, a story of a chance encounter in a crowded stellar city, a story that changed the fate of three stars and one lonely planet forever. The story that astronomers have pieced together, the most likely history of Methuselah, is a tale of cosmic theft, and it is now widely believed that Methuselah was not born where it lives today. It did not form in the chaotic, swirling environment of the pulsar and the white dwarf. To have formed at all, it must have had a more conventional beginning. Let us imagine then a scene from the very young universe. Somewhere in the nascent, still forming globular cluster of Messier 4, a young star, much like our own sun, was born. It was born from the thin, metal poor gas of that early era, but perhaps it was just lucky enough to be in a slightly more enriched pocket of the nebula. And around this young, sun like star, a protoplanetary disk formed. And from that disk, against all odds, a giant planet was born. Our planet, Methuselah. For a few billion years, perhaps, it lived a relatively quiet life. It orbited its single stable parent star, a lonely giant in a simple solar system, all while weaving its path through the dense, glittering traffic of the globular cluster. But in a place as crowded as a globular cluster, nothing stays quiet forever. Sooner or later, paths will cross. And one day, this simple, single star system with its one giant planet had a fateful encounter. It drifted too close to another, more exotic system, a binary star system. At that time, this binary system was likely made up of two young main sequence stars, orbiting each other in a tight gravitational embrace. Our lonely solar system, with its single star and single planet, wandered into their gravitational domain, and a complex, chaotic, and beautiful dance began. A three body problem, as physicists would call it, with the planet as a fourth, smaller partner. For a time, the three stars and the planet would have orbited each other in a complex, weaving pattern, a gravitational tango of immense scale. The fate of such a system is almost impossible to predict. But the most likely outcome of such a chaotic dance is that one member is eventually ejected, flung out of the system to restore a semblance of stability. And in this cosmic game of musical chairs, it was Methuselah's original parent star that was the loser. It was gravitationally ejected, thrown out of the chaotic menage a trois, and sent to wander the globular cluster as a lonely, starless sun. And Methuselah? Methuselah was captured. It was stolen. It now found itself in a new and much more complex home, orbiting a tight binary pair of two sun like stars. It had been adopted into a new and unfamiliar family. But the story of violence and upheaval was far from over. A billion years passed. 5 billion. The two new parent stars of Methuselah began to age. And because they were in a tight binary orbit, they did not age gracefully or quietly. The more massive of the two stars was the first to run out of hydrogen fuel in its core. It began to swell, bloating up into a colossal red giant. As it expanded, its outer layers of gas began to spill over onto its smaller companion star, a process known as mass transfer. Great, brilliant streams of stellar material would have flowed from one star to the other, a fiery bridge connecting the two suns, all while the ancient planet Methuselah continued its long, silent orbit around them. This mass transfer had a profound effect. The star that was losing mass had its life cut short, and it quickly collapsed into the dense, compact object we know today as a white dwarf. The other star, however, the one that had been feeding on its companion, now had a new lease on life. It had gained a huge amount of extra mass, causing it to burn hotter and to spin faster and faster. This star, gorged and rejuvenated, eventually also ran out of its fuel and ended its life not with a quiet sigh, but with a spectacular bang. It exploded as a supernova, one of the most violent events in the entire universe. For a brief period, the supernova would have blazed with the light of a billion suns, illuminating the entire globular cluster with its brilliant dying light. It is almost certain that this colossal explosion would have blasted the ancient planet Methuselah with an incredible amount of radiation and stripped away any atmosphere it might have once possessed. It is a wonder that the planet was not destroyed entirely or knocked out of its orbit, but somehow it survived. And what was left behind after the supernova? The super dense, rapidly spinning core of the exploded star, the pulsar. And so the final bizarre configuration was set. The ancient stolen planet Methuselah, the survivor of a chaotic gravitational dance and a nearby supernova, now found itself orbiting the two strange corpses of its adopted parents, a spinning neutron star and a quiet white dwarf. This is the third great impossibility, the sheer, unadulterated improbability of its own life story. For this sequence of events to have taken place, the formation in a metal poor environment, the capture by a binary system, the survival of a mass transfer phase, and the endurance of a nearby supernova explosion, is a chain of coincidences so unlikely that it borders on the miraculous. It is a planet that has lived through more violence, more chaos, and more change than any world we can easily imagine. And yet, it is still there. It continues its long, slow 200-year orbit around its two dead suns, a silent and patient witness to some of the most extreme events the cosmos has to offer. It shouldn't exist because its ingredients were not available. It shouldn't exist because its neighborhood is too dangerous. And it shouldn't exist because its life story is a statistical impossibility. It is a cosmic ghost in every sense of the word, a survivor from a time that should not have been able to build it, in a place that should have destroyed it, after a history that should have been impossible. And the lesson of Methuselah is a profound one. It is a lesson in cosmic humility. It teaches us that our neat and tidy rules and our elegant recipes for creation are just that, our rules, our recipes. They are the first draft of a story that the universe is still writing. And the universe is a far more creative, far more resilient, and far more surprising author than we often give it credit for. Planets like Methuselah are the plot twists. They are the unexpected characters that show up and force us to rethink everything we thought we knew. They remind us that in a universe with 100 billion galaxies, each with 100 billion stars, the improbable doesn't just happen. It happens all the time. The one in a million chances, the one in a billion chances, are played out over and over again, and the result is a cosmos filled with beautiful, strange, and impossible wonders. But Methuselah, as ancient and as impossible as it is not the only ghost in the cosmic graveyard. As we have looked deeper into the exoplanet zoo, we have found other worlds that challenge our understanding in completely different but equally profound ways. To meet our next impossible world, we must leave the ancient, crowded city of the globular cluster, travel to a place that feels, at first, much more familiar. A single young star wreathed in the dusty leftovers of its own creation. Our journey so far has taken us to the very edge of cosmic history, to meet a world that survived the impossible. Methuselah's story is a grand, sweeping epic of age, violence, and incredible luck. It is a story of an individual survivor, but the universe has other ways of showing us the flaws in our neat and tidy recipes. Sometimes the impossibility is not written in a planet's history, but in its very proportions, in the fundamental relationship between a parent and its child. To find our next impossible world, we travel to a star system much younger and, on the surface, much more conventional. We journey to a small, cool red dwarf star located about 300 light years from our own sun. Red dwarfs are the most common type of star in our galaxy. They are the quiet, frugal, and incredibly long-lived majority. They are much smaller, much dimmer, and much less massive than our own sun. And according to our standard model of planet formation, our cosmic cookbook, the size of a star should have a direct relationship to the size of the planets that can form around it. A large, massive star will have a large, massive protoplanetary disk, rich with material to build giant planets. A small, lightweight star, like a red dwarf, will have a much smaller, much less massive disk. There is simply less raw material available to work with. Therefore, our theories predicted that while red dwarf stars might be excellent places to find small, rocky, Earth-sized planets, they should be very poor places to find colossal gas giants. The nursery is simply too small to raise such a large child. There shouldn't be enough material in their protoplanetary disks to form the massive core needed to trigger the runaway gas accretion that builds a world like Jupiter. It is a simple and logical rule of cosmic proportions. A small star should mean a small planetary system. And for a long time, this is what our observations seem to confirm. We found many rocky worlds around red dwarfs, but very few gas giants. The rule seemed to hold until we found the giant that shouldn't be there. Around a particular red dwarf star, officially named TOI 5205, astronomers found a planet, and not a small, rocky one. They found a colossal gas giant, slightly larger than our own Jupiter. This planet, designated TOI 5205b, is a true behemoth, and its existence, circling its tiny parent star, breaks this fundamental rule of cosmic proportions in the most spectacular way. To put it into perspective, our own sun is a giant compared to Jupiter. The sun accounts for over 99.8% of the total mass of our entire solar system. Jupiter, as massive as it is just a small companion. The parent star is overwhelmingly dominant. But in the TOI 5205 system, the relationship is shockingly different. The parent red dwarf star is only about 4 times more massive than the planet that orbits it. It is less like a star and a planet, and more like two celestial siblings of almost equal standing. The planet is so comically oversized for its star that if you were to scale them down, it would be like a tiny pea being orbited by a very large grapefruit. This is our second great impossibility, a planet that is simply too big for its parent. It is a profound challenge to our understanding of the accretion model. When astronomers run their simulations trying to form such a massive planet from the small, lightweight disk that should surround such a small star, they fail. The models simply cannot gather enough material quickly enough to build the planet's core before the disk of gas and dust dissipates. The recipe fails every single time. The planet TOI 5205b sits there in the cold, faint light of its tiny sun, a quiet and profound rebuke to our theories. It is a testament to the fact that there may be other ways to build a world, other recipes in the cosmic cookbook that we have not yet even begun to imagine. Perhaps this giant was not formed by the slow, patient process of core accretion at all. Some astronomers have suggested that it might have formed through a much more rapid and chaotic process known as gravitational instability. In this model, a protoplanetary disk doesn't form a planet from the bottom up by slowly clumping small particles together. Instead, if the disk is massive and cold enough, it can become gravitationally unstable and collapse in on itself, forming a giant planet in a single rapid event, bypassing the need for a large core. It is a more violent, more direct, and less common way to form a world, and it might be the only way to explain these impossibly large planets around such impossibly small stars. But this is not the only such defiant giant we have found. Across the galaxy, we are beginning to find a whole class of these forbidden planets, worlds that are too massive for their stars, or worlds that orbit too closely, or worlds whose orbits are tilted in strange and inexplicable ways. Each one is a beautiful individual puzzle. Each one is a quiet whisper from the cosmos telling us that our story of creation is still incomplete. And some of these worlds are impossible not because of their size or their age, but because of where they choose to live. They are found in places where the universe itself seems to forbid their very existence. To meet our next and final example, we must journey to a place of incredible violence and power, a place that makes even the chaotic heart of a globular cluster seem peaceful by comparison. We must journey to the immediate vicinity of a supermassive black hole. At the center of our own Milky Way galaxy, there lies a sleeping giant, a supermassive black hole named Sagittarius A star, a point of immense gravity 4 million times more massive than our Sun. It is the anchor of our galaxy, the calm eye of the cosmic storm. But its immediate surroundings are anything but calm. This is one of the most extreme environments in the entire galaxy. The gravitational forces here are immense, creating powerful tidal forces that can rip apart entire stars that wander too close. The region is also bathed in intense X-ray and ultraviolet radiation from the hot gas swirling around the black hole and from the dense cluster of massive young stars that live nearby. This is, by all accounts, a cosmic desert for planet formation. The intense radiation should evaporate any protoplanetary disk before it has a chance to form planets. The powerful tidal forces from the black hole should tear apart any clumps of gas and dust that do try to gather. This is not a stellar nursery. This is a stellar graveyard. It is a place where worlds should be unmade, not born. And yet, right there in that celestial furnace, orbiting some of the massive young stars that cling close to the black hole, we have found them, a population of young, giant planets, worlds that are thriving in a place where, according to our rules, they should have been instantly destroyed. This, then, is our final and perhaps most profound puzzle, a nursery of worlds in the heart of a cosmic furnace. Young, giant planets calmly orbiting their parent stars just a few light years away from a gravitational monster that should have forbidden their very conception. This is not just a single anomalous world like Methuselah, born of incredible luck. This is an entire population of impossible worlds. They are a quiet, defiant chorus singing a song of creation in a place that should only know destruction. How can this be? How can planets form in such a hostile and unforgiving environment? The discovery of these worlds has sent astronomers and astrophysicists back to their drawing boards, forcing them to consider scenarios that were once thought to be the stuff of science fiction. The Cosmic Cookbook, it seems, has a secret chapter, one reserved for the most extreme kitchens in the universe. One idea is that these planets are not natives. Like Methuselah, perhaps they are immigrants. This theory suggests that these planets did not form where we see them today. Instead, they were born in a much more peaceful and conventional environment, in a stellar nursery far away from the chaotic galactic center. They formed around their parent stars in the usual patient way, in a calm and orderly protoplanetary disk. But their story did not continue peacefully. The entire star cluster in which they were born, a traveling city of young, bright stars and their fledgling planetary systems, was on a collision course with the heart of the galaxy. Over millions of years, this entire cluster migrated inwards, drawn by the immense gravity of the supermassive black hole. As it got closer, the powerful tidal forces of the galactic center began to rip the cluster apart, scattering its stars like seeds thrown to the wind. But some of the most massive stars, with their tightly bound giant planets, were able to hold on. They were captured into tight orbits around the black hole, becoming the young, bright stars we see there today, their impossible planets still faithfully circling them. In this scenario, these worlds are not miracles of in place formation. They are the hardy survivors of a great and ancient migration. They are cosmic refugees, now making their home in one of the most dangerous and sought after pieces of real estate in the entire galaxy. It is an elegant and dramatic story. But there is another, perhaps even more wondrous possibility. What if these planets are natives? What if the universe has a way to build worlds even in the heart of such chaos? A second theory proposes a new and very different recipe for planet formation. It suggests that these planets were not born from the slow accretion of dust and pebbles in a thin, flat disk. Instead, they were born from a single, massive, and turbulent disk of gas that once surrounded the supermassive black hole itself. In this model, the disk around the black hole was so massive and so gravitationally unstable that it didn't form stars in the usual way. Instead, it fragmented directly, collapsing in on itself in multiple locations to form not just the massive stars we see, but also at the same time, their giant planetary companions. The star and its planets would have been born together in a single, rapid, and chaotic event like cosmic twins. This top down model of formation, driven by gravitational instability, is a radical departure from the gentle, bottom up story of core accretion we are so familiar with. It is a recipe for a universe that is in a hurry, a universe that can build worlds in a flash of gravitational violence without the need for the slow, patient work of dust bunnies clumping together over millions of years. We do not yet know which of these stories is the true one. Perhaps both are true. Perhaps the universe, in its infinite creativity, uses many different recipes to build its worlds, each one tailored to the unique ingredients and conditions of its local environment. But the existence of these planets, right on the doorstep of Sagittarius A, is a profound statement. They are a final, definitive proof that our simple, homegrown theories are not enough. They are a testament to the fact that the drive to form worlds, to create structure, to gather matter into beautiful, complex, and orbiting systems is one of the most fundamental and persistent forces in the entire cosmos. It is a force that can overcome the chaos of a globular cluster, a force that can defy the proportional limits of a tiny star, and a force that can even stand and thrive in the face of the overwhelming power of a supermassive black hole. And so our journey in search of the planets that shouldn't exist comes to a gentle and quiet close. We have traveled to the dawn of time to meet an ancient survivor. We have visited the court of a tiny star to witness a comically oversized giant. And we have stood at the fiery gates of the galactic center to see a nursery of worlds blooming in a cosmic desert. Each of these worlds, in its own unique and beautiful way, has torn a page from our cosmic cookbook. They have shown us that our understanding of the universe is and always will be a work in progress. They are the beautiful, defiant ghosts in our neat and tidy machine of theory. And this is perhaps the most important lesson of all. The goal of science is not to arrive at a final, unchanging set of rules. It is to remain in a state of constant, gentle, and humble wonder. It is to be open to the possibility that the universe is always more strange, more creative, and more beautiful than our last, best theory. These impossible worlds are not failures of our understanding. They are invitations. They are gentle whispers from the cosmos inviting us to look deeper, to think more creatively, and to expand our sense of what is possible. They are the universe's way of keeping us humble. They are the universe's way of keeping the story interesting. And so now, as our long and gentle journey comes to its end, let us bring our awareness back from these distant, impossible worlds, back from the ancient, glittering city of the globular cluster, back from the court of the tiny red dwarf, back from the fiery, chaotic heart of our own galaxy. Let us bring our awareness all the way back to this room, to this bed, to this singular, quiet, and precious moment in time. We began our journey with the comforting idea that there are rules to creation, a gentle and reliable recipe for building a world. And then we met the beautiful exceptions. We met Methuselah, the ancient survivor, a world that teaches us about the profound power of resilience and the surprising creativity of the early universe. We met the comically oversized giant, TOI 5205b, a world that teaches us that proportions are not always what we expect, and that there are many different ways to grow. And we met the brave young worlds at the galactic center, a nursery of planets that teaches us that life and creation can thrive even in the most seemingly hostile of places. Each of these worlds, in its own way, is a beautiful and necessary puzzle. They are the anomalies, the outliers, the ghosts in our tidy machine of cosmic theory, and their existence is a profound and gentle gift. They are the universe's way of reminding us that our knowledge is just a small, flickering candle in a vast and beautiful darkness. And that darkness is not something to be feared, but something to be explored with a sense of wonder, humility, and awe. There is a deep and quiet comfort in this realization. It frees us from the need to have all the answers. It allows us to simply rest in the beauty of the mystery. The universe is not a solved problem to be filed away. It is a living, breathing, and unfolding story, and we are lucky enough to be a small part of it. And perhaps in our own lives, there is a gentle lesson to be learned from these impossible worlds. We too have our own sets of rules, our own recipes for how we think life should be. We have expectations for ourselves, for others, for the path our lives should take. And sometimes when things don't go according to plan, when our own lives feel a little bit impossible, we can feel a sense of failure or chaos. But maybe these moments are just our own personal impossible planets. Maybe they're the universe's way of showing us that our own personal recipe book is too small. Maybe they're invitations to be more creative, more resilient, and more open to the surprising and beautiful ways that a life can unfold. Perhaps the most beautiful parts of our own stories are the ones that defy all our expectations, the ones that, by all rights, shouldn't be there. So now, as you lie here in the quiet and the dark, let these cosmic stories be a gentle companion. Let the resilience of Methuselah remind you of your own strength. Let the defiance of the oversized giant remind you that it is okay to be different. And let the brave little worlds at the heart of the galaxy remind you that beauty and peace can be found even in the most chaotic of environments. There are no more puzzles to solve tonight, no more cosmic distances to travel. The story has been told, and all that is left is to rest in the quiet wonder of it all. Allow the gentle, steady, and inescapable gravity of sleep to be your own personal, comforting force. Allow it to pull you down into a state of deep restorative and peaceful rest. Let go of all the rules, all the expectations, all the thoughts of how things should be, and simply allow yourself to be a small, unique, and beautiful world drifting peacefully in a vast and mysterious cosmos. Thank you for joining me on this journey to the very edge of possibility. I hope it has brought you a sense of wonder, a feeling of deep comfort, and a profound and lasting sense of peace. If you have found a moment of calm here in our quiet corner of the universe, a like or a subscription is always so deeply appreciated. It helps this small, drowsy cosmos of ours to continue its gentle exploration of the great, beautiful, and sleepy mysteries of existence. But for now, all the stories have been told. All that is left is the silence. All that is left is the gentle darkness behind your eyes. All that is left is the slow, steady rhythm of your own breath, a quiet and constant reminder that you too are a small and beautiful miracle in this vast and wonderful universe. Sleep well. Dream of impossible worlds. The universe is far more imaginative than we are.